Alright, hi. My name is Whitney Powell, and this is my final project presentation for the Big Data Analytics class at the Harvard Extension School. I'm just going to load up the slideshow here. Alright. My project topic is Impala, and in this presentation I'll introduce you to this technology, talk a little bit about installation, and I'll also introduce you to the example problem I ran for my final project report. Alright, let's move on. Of course, the first thing I need to cover is, what is Impala? Well, Impala is a technology created by the Cloudera company. It is an open source version of Google's Dremel project. Impala supports real-time queries of extremely large data sets that have been stored in the Hadoop file system or in Apache Base, HBase, excuse me. Impala is exciting because not only is it a real-time technology, but it also can, in particular instances, when the data set is right, and there are actually quite a lot of these, in particular instances, Impala can run faster than the same type of MapReduce queries. This pretty much occurs because MapReduce has a really big overhead. So for really complicated problems, I mean, MapReduce is the clear winner, but Impala uses a different set of algorithms that are really, really fast for the right data set, in a small, fast query. So it actually uses a set of parallelized query systems. So I want to talk a little bit about what Impala isn't before we get into a little bit more about Impala. Impala is not MapReduce. It's easy to get all these services confused about what they are underneath, but Impala is very specifically not syntactic sugar on top of MapReduce commands. In fact, it uses a completely different set of algorithms to solve the big data queries. Of course, then Impala is also not Hive, which is really just MapReduce underneath with this sort of SQL-like structure on top. Impala does, however, use these sort of SQL-like commands, very similar to Hive, and designed on purpose to look a lot like Hive, to look a lot like SQL. So you do see it looks very similar. But they're very, very different products. They work on, they have different reasons to be used, and I do want to point out that Dremel, which Impala is based on, also has a column-based structure for its data that's really, really effective for speeding up both these type of queries with Impala or Dremel, as well as ones for MapReduce. But Impala does not include that natively. It will be included in a future product that can be used with Impala or with MapReduce. When those two products are combined, it will be as fast or faster than the Dremel product, or at least that's the idea. So one other thing what Impala isn't, Impala is not SQL. Impala runs on large distributed data sets across many CPUs, so it's a very different type of product, even though they look very similar. Right, but in a similar vein, does Impala replace MapReduce, Hive, or SQL? Well, no, of course not. Impala is an important place in the set of Hadoop technologies, but it's not a replacement. Well then, you might ask, when do we use Impala? Well, Impala is especially well suited for running simple and fast queries over a large distributed data set. This data set needs to be a fairly simple, structured, but nested data from simple file types. If the data set's not very big, go ahead and use a traditional database system like SQL. Also, I want to point out, we're talking about really, really big data sets here when we talk about, big, right? I mean, these are many CPUs and huge masses of data. For really small things, and for most examples you're going to see, most tutorials, my example, it's a little too small to really take advantage of the capabilities of something like Impala, which is a set of parallelized algorithms. So, but most of the time it's easier to test it on something a little bit smaller. If the query isn't simple, or you expect it's going to take a long time, Impala is also not the best choice. It's not really robust in the same way that MapReduce is. It doesn't have that capability to really handle CPU failures, and it can't really run complicated problems. It's built on a lot of other technologies, and so at least right now it's not the best solution for something hefty. Also, currently Impala can only handle text and sequence files natively. So if you wanted to use something like XML or CSV, then you either need to wait till they come up with the ability to do that, which should be soon, especially for common file types. But you're going to need to pre-process, which isn't a huge deal, of course, but it is a bit of a limitation. Impala also has a couple of little features Dremel doesn't. I wanted to point out I forgot about earlier, or at least one important one, is that it can handle more than one set of data at one time, more than one table, and run queries on those. At least at the time that Dremel, the publication of the original book of original paper on Google's Dremel project, that was not the case. All right, I want to go ahead and tell you a little bit about installing Impala because it's a relatively new technology. So it's not nearly as well documented as Hadoop or Hive, and I found the installation process to be a little bit tricky. So I just wanted to at least go over the couple of major ways that you go about it. I use this first one here, Cloudera VM and the Cloudera Manager. So what this is a pre-made virtual machine produced by the Cloudera people, and then Cloudera Manager is this sort of browser-based GUI for installing and setting up the CDH4 components like Hadoop and Hive, and these sorts of things along with Impala. So the Cloudera Manager is great. I use the free version. There's a professional version as well. But it's really fantastic for getting things installed quickly, easily. You can also set it to maintain and that sort of thing. Pros, of course, easy to install. There's really no commitment to the software here. The biggest problem I ran into is that the Impala, this virtual machine, has very specific requirements for the machine you're running. It's got to be a 64-bit OS. It really needs 4 gigabytes of RAM. Pretty much as much hard drive space as you're willing to give it. That can be a little bit of a problem now and again. So it's a little bit hefty. You can of course install it manually. Pros, you get more control. It's more resource efficient. Cons, I mean, you've got to install it manually, which can be a lot of extra work. I haven't done this, so I'm not sure. Maybe it's incredibly easy. But there's just a lot more chances of problems and conflicts. And anyway, these are systems that are supposed to be run on many computers. So if you're installing Impala, most likely you're just testing it out, getting used to the query system and that sort of thing. So I'd recommend just going ahead and going with a simple solution, at least at the beginning. Of course, you can also run Impala, on a cluster of your own or Amazon's cluster system, which, of course, for production use is a much better solution and some really neat stuff to do it that way. All right, I want to introduce you. Running a little bit out of time here, but I did a simple example. In my report, I mostly set up Impala, got all this stuff working, and then I showed how taking like a reasonably big data file, but honestly still nothing close to what you would do in a production environment or what really takes advantage of Impala's strengths. But it's a great big file of speech tagging data, and that's what I have here. A little bit of an excerpt of this part of speech tagging data file that I found online. So you have like the word cartograph here, followed by the letter N, capital N, which says that cartograph is a noun, or at least most of the time. Part of speech tagging data is very useful for natural language processing applications. So, all right. So in order to use this data with Impala, there are 3 major steps. First, you need to load the data into the Hadoop file system. We've all done this many times now, so no need to go over that. Next, you need to create an Impala table that holds our data. For that, I created a setup file, which I'll show you on the next slide. Then to run that file through the Impala shell, you can use this command I've got here. It's really just sort of like calling the Impala shell and telling it to run the commands in this file. You could actually do this through the interactive shell as well, or through one-by-one line commands, which is the other option. But this is the similar type thing to what you see in the documentation. Then you're able to use Impala, run queries on the table, examine the table, and that sort of thing. Here's the setup file, as I promised. It's really straightforward. First line just says, if this table exists, go ahead and get rid of it. Then you create a table. I called it POS for part of speech. It has two variables. There's a word variable, which is a string, and the POS variable, which is a string. So there's a word, part of speech, as we saw earlier. And the location is relative to the Hadoop file system. So now that you have your data that has been loaded into the file system, you now run this file, which transforms that data into an Impala table. All right, now that you've done all of that, it's time to run the Impala shell, which is really simple. Just, all right, Impala-shell, press enter on a terminal window, and you'll have the ability to run a whole bunch of SQL-like commands. Some of the common ones are select, count, describe, show, explain, insert, and limit. They do probably what you would think they would do. You can press, I think, either tab or tab twice, I can't remember, to look at the possible commands while you're in the interactive shell. Select selects gathers parts of the table. So if you say select star, it's selecting everything. You could say there's a limit command. You could say select star limit 10, so it brings you 10 items, 10 rows from the table, that sort of thing. Counts things. If you say count star, it'll count all of your rows, this sort of thing. And now I'm going to go ahead and show you a couple of examples, not even close to what Impala can do, but a couple of things I thought were neat. So first, you can examine the table. To do that, you would use the describe command. So what I have here is describe POS. Semicolon is necessary for Impala. So I do that, and then it repeats the query to me and runs the result. This is really nice if you want to check to make sure your table loaded correctly, at least has the kind of idea that you were looking for. As you can see, it's very fast, 0.11 seconds. And then we have the explain command, which is really, really neat. Explain tells you how Impala goes about returning the information for that command, what its steps are. And since, like I've said before, Impala is not MapReduced and runs in a different way, it's really neat to see the different parts. My command here, select, so you start with explain, and then you put a command. And so that command is select count star from POS, where POS equals A or POS equals NA. So what this says is count all of the parts of speech where the parts of speech are equal to A or NA. And you select those rows and count them. So yeah, and explain here just shows you what's happening. So anyway, that's all I have for today. I am just barely under time, so I'm going to go ahead and leave you. I do have many more Impala example commands in my report if you're interested. However, if you're curious about the system, I'd recommend setting up the virtual machine and trying it out yourself. Once you get the system set up, the rest is really intuitive, and it's actually pretty fun. So, yep, thanks.